Hi class, this is our 8th lesson in statistics and our first for this new topic, chapter 6, discrete random variable. Let us understand discrete random variable. Now all these three words are very important in this lesson. We studied this in the class, discrete and continuous. Discrete data, if I ask you how many students in the class, you will never say 7.3 or 7.8. Now those datas without decimals are called discrete, we studied. Random, something which is not pre-planned or what comes, you don't know what is going to happen before doing the experiment. It's called random. Variable, we all know variable, opposite of constant, and when answer can vary, variable, it should not be a constant. Okay, in this topic we'll be learning about how to draw probability distribution. This table here, this table is called a probability distribution. Where x, let us say this is the sample space. If you throw a dice, you can get a 1, you can get a 2. So this first row represents the sample space of getting the number, okay, when you roll a dice. And then the probability of each individual outcome is written under it. What is the chance of getting a 1 when you throw a dice? It's 1 by 6. Chance of getting a 2, 1 by 6. So when you write the associative probability next to the outcome, this is called a probability distribution function. This is what we are going to study. Okay, the rest you can read this page, pause and read. Let's go ahead. Let us take this example. Write down whether or not each of the following is a discrete random variable. Discrete random variable. Give reason. The first one, the height, x centimeter. Clearly height, height is continuous. Height cannot be discrete. So this is definitely not discrete. So it cannot be a discrete random variable. So the answer is it's not. The number of times, where r represents number of times, a 6 appears when a fair dice is rolled 100 times. So when you roll a dice 100 times, how many times you get a 6? See, you can get a 6 only one time. You can get a 6 2 times, 3 times, 4 times. So number of times is clearly discrete. You cannot have 7.3 times. Okay, so this is discrete. This is random. You will only know after you perform the experiment. Nothing is planned here. And variable, the response will keep on changing. You can get 1 6, you can get 2 6, you can get 95 6, you can get 99 6. So it's a variable. So this is definitely a discrete random variable. The last one, the number of days, w. So w is representing number of days in a given week. See, number of days, discrete random, forget about everything here. This is not even a variable. Number of days is a constant number. There are always 7 days in a week, so there's no question, you will always get 7. So this is not a discrete random variable because it's not a variable, it's a constant. Okay, let us start our lesson now. Okay, now there is a probability distribution table given to you. There are 4 outcomes and the probability associated with each outcome is written here. And now we studied before, we all know the total probability will always be 1, correct? So this plus this plus this plus this should give you 1, and that is how you can find k. So basically 1 plus this, the probabilities will add up to 1. You simplify this equation, you solve, you'll get the answer for k. That's it. Next. Now see, this is called a piecewise function. This is there's different definition for the outcome. So for when x is 1 and 3, you will use this formula. When x is 2 and 4, you will use this formula to construct the probability function. So you will draw a table now. The outcomes are 1 2 3 4. So in your table the x values will be 1 2 3 4, and then based on this formula you will fill the probabilities. Let us see. So you have x, it could be 1 2 3 4, okay, and the probability. So when x is 1, the formula is kx. So 1x is 1k, which is k. When x is 2, we come here now. 2 represents the second formula. So when x is 2, it will be 2 minus 1, which is again 1 into k, 1k. So that's why this is k. For 3, 3 is here, so you will use this formula. So 3 into k is 3k, and hence you can complete the probability distribution table. We know the sum of all of this will give me 1, and that is how I can find k. And the last part of the question says find the probability that x is greater than 1. Greater than 1, remember 1 cannot be counted in greater than 1. So greater than 1 means k plus 3k, which is 7k. Or 7 into 1 by 8, which is 7 by 8 is the answer to part B. Okay, next. Okay, They have given you a probability distribution table here. The question says find the probability where x is between 1 and 3, but remember 1 is not included, so we cannot count 1. We have to start from 2, and 3 is included because it is less than equal to 3. So it's a probability of getting 2 and getting 3. So it's 1 by 2 plus 1 by 8. 1 by 2 plus 1 by 8, 5 by 8 is the answer to part first question. Less than 2. Again, 2 should not be counted. 2 is not, it's not equal to 2. Less than 2 is 0 and 1. So you add the two probabilities, you'll get the answer. Greater than 3. There is no outcome greater than 3, so probability is definitely 0. Clear? Let's go ahead. Okay, now this is a nice big question, so be careful. Pay attention. A fair five-sided spinner. There is a fair means they are all equally likely. All of them are 1 by 5, 1 by 5, 1 by 5. So there two are red, 2 are blue, 1 is yellow. And now the question is, they're asking us to draw a probability distribution function for the first one, x, where x is number of times red appears. And remember, you are spinning it 5 times. Given that a spinner is spun 5 times. Okay, so we are spinning it 5 times, and we are checking how many times you can get a red. So definitely, if you maybe not a single time red appears. When you spin it 5 times, maybe all 5 times it is landing on other colors. So there can the distribution could have outcome as 0. You can get 1 red, 2 red, 3 red, 4 red, 5 red, maximum 5 red. Correct. So our outcome for x will start from 0 till 5, and then we'll write the associative probability. Let us take the table. So now we can get 0 times 5, 1 times 5, 2 times till 5 times 5. Now let us look at the probabilities. So when you don't get any red, that means all 5 times you get not red. So it's probability of not red, not red, not red, not red, not red 5 times. The probability of getting a red is 2 by 5. Okay, which is 0.4. So the chance of not getting a red is 0.6. So it will be not red, not red, not red 5 times. So 0.6 into 0.6 into 0.6 into 0.6 will give you 0.6 to the power 5. So this is the chance of getting all reds, all not reds. And now getting a red 1 time means 1 time you get a red, but the other 4 times you get not a red. So it is red, not red, not red, not red, not red, something like that. So chance of getting a red is 0.4. I said something like that for some reason. You will know now. 0.4 times not red, not red, not red 4 times. And you see that you have to times it by 5. Now this is very important to note. This is called number of arrangement. Okay, we always times it by number of arrangement. Let us understand what is arrangement here. See, getting 1 red, there are 5 different ways in which you can get 1 red. It could be first red, then not red, not red, not red, not red. Or it could be first not red, then red, not red, not red, not red. And similarly, you can have this possibility, this possibility, this possibility. So there are 5 ways in which one can get 1 red and 4 not red. So it will be probability of this plus probability of this plus probability of this, and so on. When you add something 5 times, it is as simple as multiplying it by 5. That is why when you see more than one ways of a chance happening, you have to find the arrangements. This is called first arrangement, second arrangement, third arrangement. So there are 5 arrangement or 5 ways. You just multiply by the number of arrangement. The probability times the way in which you can arrange them. Okay, that is why we are multiplying it by 5. There is a shortcut way of doing it. This, you don't have to do all of this. There are total 5 outcomes, out of which you want 1 red, or 1 red. So you can say 5 combination. You can do shift and divide in your calculator. You will get C. So 5 combination 1. From you want 1 red from total of 5. See, 1, 2, 3, 4, 5. From total 5 red, you want 1 red. So from total 5 combination of 1. You can even write 5C4. You'll get the same answer. You'll get 5. Counting 4 not red. 1, 2, 3, 4. So whether you take 5C1 or you take 5C4, you will get 5. So this is just a shortcut way of not doing all of this. Similarly, this means you're getting 2 red and 3 not red. So red 0.4, again red 0.4, that's why you squared. Not red, not red, not red, that's why you cube, and times it by 10 because there are 10 arrangement, 5 arrangement, and let us take this also. See, 10 arrangement. I don't want to write all 10 here. So, but you can, if you want to try, give it a try. It will be red, 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 not red, not red, red, not red, red, not red, not red. Like that, you can go for 10 possible arrangements. We'll use this shortcut that we studied here. There are total 5, out of which you want 3 red. So you can go for 5C3, or even if you want to take from not red, you can say 5C2 not red. So there is a combination of 4 not red, or there is a combination of 1 red. So you can say 5C1, 5C4, same thing here. You can take 5C3 or 5C2, both 5C3 and 5C2 are one and the same. You'll get 10. So this is how you can find this number, and that's it. The second part of the question says find the number of times yellow appears. Everything is going to be same. The only thing is red was 2 by 5, yellow is 1 by 5. Okay. So the probabilities will change. The procedure is 100% same. So that's the table here. All not yellow, yellow, 4 not yellow, 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 not yellow, not yellow, not yellow, and so on. Okay. Now this part of the question I'll take in the new slide. The question says the spinner is now spun until it lands on a blue. So the game is something like, or if it was a game, you spin. If it comes on a blue, you stop. The game is over. Finish. If it is not a blue, then you try again. Second time, if you get a blue, you stop. If it is not a blue, you keep on going, but you stop anyways after 5 tries. So you stop at a blue or until you have been spun 5 times. Okay. I want you to pause your video here and try to write all the possibilities of this experiment. So you can spin only one time, getting a blue and stopping. Finish. You got a blue in the first try. Or it could be not a blue, then a blue. So try doing it and then you see the answer. So now I have written all the outcomes here. So there is a possibility of getting a blue and the experiment will stop. Not a blue, then a blue, and then you stop in 2 tries. This is not blue, not blue, blue. 3 tries, 4 tries. Now see, 5 tries. This is where students do mistake in exam. Don't forget. See, you can have not blue, not blue, not blue, not blue, and blue, and then you stop. Or it could be all 5 not blue, and anyways after 5 you have to stop. So in 5 tries, it could be this also, or it could be this also. Let us represent this in a probability distribution. So our outcome, it could be in 1 try. So that's why I took 1, 2 try, 3, 4, 5. So 1 is probability of getting a blue. Probability of getting a blue is 2 by 5, 0.4. 2 times it could be not blue, blue. So not blue is 0.6 times blue. Not blue, not blue, blue. So not blue, 0.6 multiplied by 0.6 multiplied by 0.4. Not blue, not blue, not blue, blue, and so on. Clear? Let's go ahead. Okay, this question I want you to solve on your own. This is question number 13. Read the question carefully. This is a formula. They're saying explain how you know that this function does not describe a probability distribution. When you do this, when you try to work on it, it's very easy. This is not probability. This will not describe a probability distribution, but this you can find how to find k. With 2 it will not work. It will work with some k. You will, when you try to do it, you will know exactly why. Try it on your own first. I'll give you a hint. The total probability has to be 1. Next question. Okay. Now coming to finding what we studied now was probability distribution. Now we're going to cumulative distribution. See, cumulative is studied before in median and all. When you keep on adding, it is called cumulative. Okay. What is that doing here? See, that function and cumulative distribution is written with fx in this chapter. Okay, in discrete random variable. So f of x, there's a formula. It is probability of all outcomes less than equal to that number that you're working with. For example, f3 means probability of everything less than 3. Or cumulate, you add them. Add everything till 3. So probability of 1 plus 2 plus 3 is nothing but f3. So f4 will be probability of 1 plus 2 plus 3 plus 4 and so on. Okay. And now this is very important. Please go through this with me now. I can say f1 and f2, p of x equals to 1 plus p of x equal to 2 can be written as p of x less than equal to 2. Correct? This is same as this. And this I just wrote as it is. Now this by the same formula, this is nothing but f2. So f3 can also be written as f2 plus probability of 3. Now if I make this the subject, it will become f3 minus f2. So this is very important. It is used when they give you a cumulative distribution function in exam and they ask you to draw a probability distribution, so from cumulative to probability distribution function you need to use this formula. So to find probability of x equals to 3, you will do f3 minus f2 and so on. Let us take example now. Okay, this question, a random variable x has a probability distribution function. Again, piecewise, for 1, 3 and 5 it is defined like this. For 2, 4 and 6 this is the definition, where k is a constant. Find k, we know the probability will add up to 1, and that is how this distribution for 1, 3 and 5, for 1, 3 and 5 it is just 1k, 3k, 5k, 1k, 3k, 5k, and here you have to subtract. That's why 2 minus 1 is 1k, 4 minus 1 is 3k and 5k. When you add all of this you'll get 1, and that is how you can find k. Okay, draw, you just redraw this, okay, by writing the value of k is 1 by 18. So it's 1 by 18, 1 by 18, 3 by 18, so on. Find the answer between, so you include 2 but don't include 5. So it is this plus this plus this. So 3 plus 3, 6 plus 1, 7k is the answer. Okay, 7k. Same, f4, the formula we just studied. F4 means probability f px less than equal to 4. So everything including 4. So it is k plus 3k plus 3k, and that is the answer. Okay, the last one, 1.6. See, we are working with discrete random variable. So 1.6 is same as f of 1. Please don't round, because f 1.6 means everything x less than equal to 1.6. So don't round it up. 2 is not less than equal to 1.6. So in discrete, for discrete data, f of 1.6 is same as f of 1. Okay, or everything less than 1.6 is just this. So the answer is k, 1 by 18. That's it. Okay, next. I think this is the last one. The discrete random variable x has cumulative distribution function defined by. So now this is the first time you're working with the question itself is given in terms of fx, not px. So we know the formula for fx. This was written 5 by mistake. It should be 3. And for 1, 2 and 3, this is the formula. For anything greater than 3, because the total probability cannot be more than 1. That's why anything more than that, the total will remain 1, 1, 1 and so on. Find the value of k. See, let us draw a table for f of x. So definitely the values are 1, 2 and 3. That is how I got this. Okay. Now they gave you the formula. So when x is 1, k plus 1 square by 16, k plus 1 square by 16. And now see, very important, the last number here. We studied that f of x is probability of x less than equal to that number, correct? So this is f of 3, which means probability of x less than equal to 3, and all the probabilities. So in other words, the total, the last column of fx will always should always be equal to total probability, which is 1. So this will always be equal to 1. Okay, so that should always be equal to 1, and so directly don't add them. This is not probability, this is cumulative. This is already the sum of all probability. Sum of all probability is 1. That's why k is 1. Resubstitute and you can write the table again. Now we have to find, we have fx and we have to find px. So from f we are going to probability distribution function. Clear? You will use that formula we studied of getting x equals to 3 was f3 minus f2. Let us take this. So when you are writing from cumulative to probability, the first one will come as it is. Now to get x equals to 2, you just do f2 minus f1, and you do 9 by 16 minus 1 by 4, you will get this. Similarly, to get this, you just do f3 minus f2. Like I wrote the formula again here. For probability of x equals to 3, this is probability x equals, this one is probability x equals to 3. This will be f3 minus f2. So which is 1 minus 9 by 16, and that is how you keep subtracting. You do this minus this, you'll get this answer. To get this, you do this minus this, you'll get this, and so on. That's it.